Welcome back, guys. So this is very first video of data structure where I'm going to start with the linked list. Okay. So we need to understand why do we have a linked list and how this works, what is the internal implementations of the linked list, and what are the topic we need to know in the linked list, right? So we'll start one by one. We'll go with the basic definition and then we'll go ahead with the type of linked list. So if you look at the definitions which I have written here, linked list is a data structure used to store collection of data, right? So when I say collection of data, which means when you can store multiple object of data in the linked list. Okay, we will see that how we can do that. Here try to understand the definition. So when I say collections of data, which means it is nothing but a list of data. It has following properties. Each element is connected by a pointer. Okay, maybe it sounds unfamiliar for you, but once I will show you the diagram, you will understand. Okay, try to remember this. Each element is connected by a pointer. The last element is always point to a null. Okay, because after the last element there is no any other element present in the linked list. Can grow and can shrink in the size during execution of program, because it's a dynamic in the nature. It can grow and it can shrink, can be made as long as it is required. So it's up to you whether you want to keep this object after the execution is over at the runtime or not. It's up to you. It does not waste a memory space but takes some space for processing, right? Because uh, uh, the design what we have in the linked list, we don't occupy the space in the advance. We just need some space for the processing, and memory wise it is very efficient. So whatever point I have covered here, guys, we'll try to understand through a diagram, right? So that we can correlate. Now look at the pictorial representations. What I said earlier, each node is connected by a pointer, right? When I say each node is connected by a pointer, whatever you are seeing that, these are the pointers. These are the pointers, right? And these are the node. This is the basic representations of the node. Every node will have a data and next node reference, right? When you look at the node is basically, it's nothing but it's an object, okay, which has a data of the node and which has the reference of next node. Okay, one node has a two segment. The second thing is, every the first node in the linked list, it is always represented by the head node. So always the head will be pointing to the first node. That's how we actually we determine what is the first node of the linked list. So head is always going to be the first node in the linked list, right? You can see that every node is connected by arrow mark, which is nothing but a pointer, and every node has a two segment. One is the data of the node and one is the address of the node. This also we'll understand, right? Now the last element of the linked list, it always points to null, because uh, your linked list has only 4 data, right? So after that your last node always point to the null. That's what I was talking about. Now what happens is, it can grow and it can shrink at the runtime. Okay, so let's say you are processing the linked list. Now uh, when you delete the data, this data, let's say you want to delete this data. When you want to delete the data, what happens on the runtime? Automatically this reference will get shifted here. Okay, you don't need to do I mean, your linked list will not get rearranged. So manipulation is very fast in the linked list, right? When you remove this, right? Now similarly, when you add any node, which we'll see that later, so we'll try to understand step by step, otherwise you will get confused. So for now you just try to understand, every node has a two segment: node data, node reference. The node reference is nothing but address of the second node. Okay, your first head will always point to the first node. Okay, now when I say the node reference, which means in Java what happens when you create any object, right? Let's say when you create object A, when you write obj is equal to new A, and assume that this class has parameterized constructor which will take two argument. Assume that 1 comma 2, right? Assume that. Now what happens? This object has some address. So when you perform obj to hash code, you will get some address. Let's say you will get address is equal to 100. So for this object, the address is 100, right? Similarly, here what happens when you create the first node? This node has a address in the memory. So this address is going to be the 100, right? So basically, this head will be the head address is nothing but 100. Now assume that you have created one more object, this object, second object, right? Now the second object, this guy has an address of 200. When you created the second object, it has an address of 200. Okay, now the 200 will be here. Similarly, that this guy has an address of 300. The 300 will be here. This guy has an address of, this object has an address of 400. This address will be here. Now you understood what is the reference? This is the reference. Since you have the address in the first node itself, through this address you can basically track where the next node is. Again, by this address, the third address, you can track by this address, you can track where is your next node. Now you understood how this address works, right? Because every node is nothing but it's an object. An object has two data. One is the data and second is the reference, right? Now you can go back and you can read this again. Why it does not waste memory space, we'll see that later. Going forward, try to just understand step by step, guys. Trust me, I will make sure that you will understand each and every point of the linked list, right? Now look at here, the same thing I have represented here. You have a head, okay. uh, the first node is nothing but the head node, okay. This node is nothing but head node, and head also has an address, okay. So your head has a address. The address is nothing but 50, which is nothing but your first node. So first node address is 50. Now you have here second node. You guys can see that the second node, okay, a second node is nothing but, guys, it's an object, okay. The second node has address of 100, so 100 will be here, right? The third node has an address of 200, so what happens, the 200 will be here. Now the fourth node has an address of 300, the 300 will be here. The fifth node has an address of 500, 500 will be here, and the last node will always point to null as usual, right? Now you understood. That's how we can communicate one node to other node. And in reality, whatever you are seeing that I have this diagram, it looks like it is in sequence, but in reality it's not like that, okay. In reality, one node will be here, the other node will be here, the other node will be here. Then how do you identify that, right? Because each node is connected by a pointer, and node has a data and address, right? So by looking this data 100, no matter where this node is, let's say this guy is here, right? By looking this 100, we can go and check where is the object which has address is equal to 100, right? So when we will check in the memory where is the object which has address is equal to 100, we will come to know that object is here, right? That's how we communicate. So in reality, this object will not be in the sequence, it will be scattered across the memory. And since every object will retain the address of the second object, right, by which we can identify where is the second object, where the second object has the reference of third object, your second object will identify where is the third object, right? Hope I'm clear. Now look at the basic operations which we do on the linked list. The basic operations we do insertion and deletion. This is our basic operations, right? Insertion and deletions, right? So either we insert the data into the linked list, or we delete data from the linked list, or we retrieve data from the, we read data from the linked list, which we'll see that later point of time. Now the type of linked list which I am going to cover here: singly linked list, doubly linked list, and circular list. Circular linked list. How this works, how implementations will be done, we will see that going forward. With this, I'll close the video. Hope you understood uh, how linked list looks like. How, what is the node, what is the reference, what is the last node, what is the head node. Okay, I think you got an idea of, right, what are the segment you have in the node, how each node communicates to the other node, right? Hope you got an idea. Thank you guys. Thank you for watching this.